Students, so today we'll know about some of the definitions. So definitions, first one is the electric current. Okay, so first we'll learn about the what is meant by electric current. So electric current, okay, the flow of free electrons is known as the flow of free electrons. Okay, so the flow of free electrons is nothing but is a electric current. So it's denoted by the letter I. So first we'll talk about the electric current, that is flow of free electrons. So flow of free electrons is called as a electric current, and it is denoted by I and measures its units in amperes. Okay, so we have to write is amperes, not like this. So we have to write its small letters. Okay, it's denoted by capital A. Okay, so an electric current is a flow of electric charge. Okay, so charge is nothing but is energy. Okay, so in electrical circuits, this change is carried out by moving electrons in the current. So whatever the electric current, so it will be changed from the one terminal to another. Okay, so the flow of electrons will be flowing in the electric circuit, right? So this flow of free electrons is called as a, that is current. So if how the free electrons will be flow. Okay, so energy, okay, the energy which is required for the flow of free electrons, that is the EMF. Okay, so that is the called the electromotive force. Okay, the energy which is required to flow of electrons is called as the electromotive force. Okay, so that is EMF. So electromotive force, so it is denoted by E. The units are the volts. Okay, so the energy which is required to flow of free electrons is called as the electromotive force. Okay, so this is indicated by the E, and units are the volts. Okay, and some of the definitions we have, that is the electric potential. Okay, so we'll take, so electric potential. So electrical potential nothing but, here if we take the two bodies, okay, so this body A, this body is, okay, so this having the 10 volts of voltage and other having the 6 volts. Okay, so here this charge, okay, this voltage is nothing but is this the charge. So charge means energy. Okay, so electrical potential means, so electrical potential means work done by charge. Okay, so whenever the body is charged, we can say that some work is said to be done. So if it is charged means, so it works done by the some charge. Okay, when your body is charged, we can say that the some work is said to be done in the charging it. Okay, and the charging body has the capacity to do moving other charged by either in attraction or repulsion. Okay, either attraction between the two bodies or repulsion force in the two bodies. Okay, the ability of charged body to do work is called electric potential. Okay, so that is the ability, okay, the ability of charged body to do work is called electric potential. Okay, so it can denote by, that is electrical potential is equal to, that is electric potential nothing but voltage. Okay, so is equal to work done by charge. So here work done is indicated by the W and charge indicated by the Q. Okay, so charge is the units, that is joules. You already know in that, in the physics, basics physics, right? Now there is another difference is the electrical potential, EMF. Okay, so all our similarities we have, that is electrical potential we have studied, now EMF is studied. Now here we have difference, that is a potential difference. Okay, so another definition, that is potential difference. Okay, so potentiality PD. Okay, we indicated PD. So the difference in the potential of two charged bodies. Okay, so here that is the difference between the two charged bodies. Okay, so if it consider 5 volts, here another having the 10 volts. Okay, the difference between the two charged bodies. Okay, the difference in the potential of two charged bodies is called as a potential difference. Okay, so we can write as the difference. Okay, the difference in potential of two charged potential of two charged bodies is called potential difference. Okay, it's called potential difference. Okay, so the potential difference between two charged 2 points is an electric current cause electrical. Okay, so this, okay, this potential difference causes the flow of current flow in the circuit. Okay, so that unit potential difference units are the V. V is nothing but volts. Okay, so units are volts. Okay, denoted by V. Okay, this, so if it is two if electric current is fast, okay, so it should be in a different voltage. Okay, so if it is same voltage we have, so 5 voltage here, we are also 5 volts potential, so there is no current flow. Okay, so there must be a difference. So that means here if there is the 10 volts charger, okay, here you are having the 5 volts. If it is 10 volts, here 12 volts, like if it is charge same charge by that, there is no current flow in the bodies. Okay, so always remember that the current, okay, so here the potential difference always flows from higher volt to lower volt. Okay, that is if it is higher charged bodies to lower, that is 10 volts to 5 volts body. Okay, if it's 10 volts charged bodies, then here 5 volts, so the current will flow from high to low. Okay, if it is a here, we can say here we are having the 10 volts, here another we are having the 20 volts charged body. Okay, so at that time the current will be flow like this. Okay, so always current flow from higher to lower. So that is the direction of the current in the two charged bodies. Okay, so factors on which resistance depends. So first we will take the one conductor. Here this conductor having the, here we are taking the res conductor and length we are considering the, that is L. Okay, L meters, and this area of cross sectional, okay, the conductor area cross sectional we are considering that is the A. Okay, small a. So cross sectional area, cross sectional area of the conductor. Okay, now so here we are considering the cross sectional area of the conductor A and length in meters. So cross section A, so and here cross section in the in meter square and L in meters. Okay, so here the resistance R. Okay, so the resistance R is depend upon the type of conductor. Okay, so R also, R is nothing but resistance also depend upon the type of conductor is made. Okay, so type of conductor is made. Okay, so that is the physical dimensions, okay, nature of the material, temperature. Okay, and here, so what are, how it will be varies. Okay, so for different factors. Okay, so let me consider. So first one is that R is directly proportional to the to its length. Okay, its length, R is directly proportional to the its length, so we can write as a R proportional to L. Okay, and another is that, so is inversely proportional to the its cross sectional area. Okay, so inversely proportional to the cross sectional area, so we can write as a R proportional to 1 by A. And also depend upon the type of material, depends on type of material made. Okay, next we have fourth one, that is depend upon the operating temperature. Okay, so depend upon the operating temperature. So from the first three points, so whatever we're having the, here we're having the R, right, R, L and type of material. So from this equation, so we can write as that R proportional to L by A, that is R is equal to L by A, here constant. So proportional constant we are considering, that is a rho. Okay, so here R is equal to rho L by A. Okay, so rho L by, so rho is the, okay, so it's Roman Greek letter, so it called as a, so we can write as a H rho. Okay, so it is Greek letter rho. So this is the proportionality constant. Okay, and it is this, okay, rho, and it's called as a specific resistance. Okay, it's called as a specific resistance of the material. So there is a different types of specific resistance for different materials will have, so that is indicated with the rho. Okay, that's why we are taking the, that is R proportional to its length and inversely proportional cross sectional area, and it's depend upon the type of material which is made. Okay, so here we can also say this as a resistivity. Okay, specific resistance or resistivity. Okay, so we can write as a R is equal to rho L by A. Okay, so units are the ohms. Okay, so OHM. Okay, so also we can write as in this grid. Okay, oh, next we'll talk about the specific resistance. So what is mean by specific resistance, that we have. Okay, so determine the specifically, let us consider the type of unit. Okay, so first we'll talk about the what is the specific resistance, right? So specific resistance, will in detail we go. So specific resistance, so first we'll considering the unit length and unit cross sectional area. Okay, so first we'll considering the one conductor. Okay, it's having the unit cross sectional area and unit length. Okay, unit cross sectional area and unit length, that is A equal to 1 meter square and L is equal to 1 meter. Okay, so first we are considering now the resistance of the conductor is given by, so the resistance of the conductor. Okay, so resistance of the conductor is given by R is equal to rho L by A. Okay, so here L we are considering the 1 meter and A is considering the 1 meter square. Okay, then R is equal to rho. So if we substitute these values, okay, so rho is equal to 1 and 1. So from this one we can say that R is equal to rho. Okay, rho ohms. specific resistance material. Okay, so from this one we can say that specific resistance of the material is defined. So specific resistance of material is defined as the specific resistance of the material is defined as the resistance offered by 1 meter length of a conductor material having the cross section area of 1 meter square. Okay, so here we can what we are doing that. So specific resistance of the material is defined as the resistance offered by the 1 meter length of a conducting material having the cross section of the 1 meter square. Okay, or we can also say that specific resistance of the material is also defined as the resistance of the between the two opposite faces of the unit cube material. Okay, so here we can also consider that is the cube material also. Okay, so not only so here we are considering 1 meter square line, right? So not only like this, so we can also consider the this cube also. Okay, so if it is 1 meter cube length, 1 meter cube height, then the specific resistance is also inside. Okay, so here specific resistance of the material is nothing but is the 1 meter length of the conductor of uh, the resistance offered by the 1 meter length of the conductor having the cross section of 1 meter square. Okay, that is the specific resistance. So the specific resistance units. Okay, so if you consider the specific resistance units, okay, so let me write R is equal to rho L by A. Okay, so rho L by A ohms. Okay, so here rho is equal to, that is the resistivity, rho is equal to, so from this one you can write R A by L, right? So R is nothing but ohms. Okay, so ohms, and A is nothing but meter square. Okay, and L is nothing but meter. As meter cancel, so we'll get the units ohm meter. Okay, so rho units is the ohm meter. Okay, so this is the SI units. So this is about the specific resistance of the material.